Thank you, Bonnie. Good morning, everyone. So as Reverend Bonnie said, tonight will be, or is, English is a confusing language, the first night of the holiday of Hanukkah. And I've spoken about Hanukkah here in the past, so I'm going to hit the high points. In the 3rd century BCE, the Seleucid Empire dominated and ruled the Jewish nation. And as time got on, they got more and more oppressive in their rule. And the Emperor Antiochus, or Antiochus IV, became even more oppressive and wanted to, and erected a statue of Zeus in the temple in Jerusalem, and ordered that sacrifices be made to Zeus at that temple, and essentially defiled the temple. And this was the last straw. And so after that, there was a revolt, and eventually the Jewish people won their independence. But early on in that war, they liberated the city of Jerusalem and the temple. And when they did that, they had to rededicate the temple. And that's what the word Hanukkah actually means. It means dedication. It was a chore, a big endeavor to cleanse the temple and to rededicate it. When they had finally done that, they wanted to relight it, and they found that they only had a single barrel or a single cask of consecrated oil, which would only last a single day. And it would take at least 8 days to create more consecrated oil. Nevertheless, the miracle is that they still lighted the temple with that oil, and the oil that should have only lasted a single day lasted the full 8 days. And that's why the holiday of Hanukkah is an 8-day holiday, to celebrate and commemorate that. As I say, the word Hanukkah means dedication. And it really is a dedication of the physical environment, the temple, the physical environment, to our spiritual needs. And certainly that's been going on here at the center as well. Not just with the hail damage, but throughout the year, the board has worked tirelessly to go through all the old stuff, all the old papers, all the old paraphernalia, throw out what was no longer needed, and put in some sort of an order what we still need. We got a new computer because the computer had apparently been defiled in some way. And of course, we have a new roof from the hail damage. We're getting a new ceiling. We're getting new floors. So all this renewal and rededication of the physical is really what the holiday is about. And that's why I selected that Holmes reading, where he says the physical is the spiritual, is the mental. They're really just different words for the one thing, the thing itself. Different ways of thinking about just that single one thing. And the ancients knew that. The words that we had for spirit, when we look at ancient texts, they all refer to physical things. They all refer to really breath or wind. In Hebrew, it's ruach and neshama. They both mean breath or wind. In the Greek, the word pneuma, which we say is spirit, pneuma is breath. Pneumonia, apnea, without breath. That's what pneuma means. They didn't distinguish back then between the one meaning and the other. In Sanskrit, not a biblical language, but an ancient spiritual language, prana is breath. We think of it now as sort of something, the breath carries something else, but that's not what they thought back then. Breath was prana. Breath was spirit. The word spiritus, from which we directly get the word spirit. Respiration, breath. Because breath and wind were these invisible things, you couldn't see them, but they were still a force. They still had an effect. And so that's how they thought of it, not in two separate ways. It's really the philosophers that later on sort of separated these things out. Oh, there's spirit and there's physical. To the ancients, it was one thing. It was one system, as Ernest Holmes says. One system, one thing. So again, that's why that Holmes quote I think is so apt and something to be reminded of from time to time, which is why I quoted it a number of times in my talks. Now, Hanukkah, as I say, means dedication. But in English, we call it the Festival of Lights. And the theme for this month is the light of the world. And my guess is that most of the other speakers this month will be talking about light in a metaphorical way. And so I thought I'd, again, speak of it as an actual physical phenomenon and talk about light in that way. And so rather than quote a lot of Jewish teachers like Rabbi Hillel or Rabbi Gamaliel, I thought I'd go to a different set of Jewish teachers named Albert Einstein, Stephen Weinberg, Mary Gelman, and Richard Feynman, and talk about what they have to teach us. Well, what they have to teach us is this. Physicists have identified 4 basic forces in the universe, only 4. It's what everything interacts with. To call them interactions is actually a better word than to call them forces. I'm going to talk about 3 of them briefly and then concentrate on the 4th one. So the first one I'll talk about is the weak force. Now, the weak force, even though it's called that, is very powerful because it's responsible for transformation. It's how uranium eventually becomes lead through the interaction of that weak interaction. It's how 2 hydrogen atoms fuse together to make helium through the weak interaction. And so that's how we have a sun. That's how we have the stars. Without that weak interaction, all the stars would just collapse into black holes immediately. So that's the weak interaction. It's called weak. It's still pretty important. Next one is the strong interaction. And remember back junior high school, or before that even, the atom. The atom has electrons whirling around and the nucleus, a tiny nucleus in the center. What holds that tiny nucleus in the center, what keeps it together, because that nucleus is composed of other particles, neutrons and protons. Nothing fancy here, all junior high. What holds it together is that strong force, because otherwise it would just fly apart. And in fact, what we say now is that those neutrons and protons are made of even more basic particles. And those particles are held together, the neutron itself, the proton itself, by that strong force. So it's very strong within the confines of the nucleus. But once you get outside that range, the strong force vanishes. It disappears. It's no longer of any effect once you get past that tiny little nucleus. Next force is the force of gravity. That's the one we're more familiar with. It's what keeps our butts in our seats. It's what keeps the cup here from floating off into space. But it also is gravity is what holds the sun together. The weak force is what keeps it from becoming a black hole. The gravitational force is what holds it as a single object. It's what keeps the solar system together, the galaxies together. Gravity is what makes the Earth hold together. And about the smallest thing that gravity will hold together is something about the size or the mass of the moon. It's about, because gravity is the weakest force, and anything smaller than that, gravity just can't hold together. So those are the first 3. The last force that I will talk about is what's called the electromagnetic interaction, the electromagnetic force. And it's called that because electricity we're familiar with, magnetism we're familiar with, but there are really 2 manifestations of this one interaction, the electromagnetic one. So, back to junior high, or before, electrical charges come in 2 delicious flavors, positive and negative. And it was actually Benjamin Franklin who named them that, positive and negative. And we remember that the positive ones, if you have 2 positive ones or 2 negative ones, 2 of the same sign, they will repel each other. They will push each other apart. If you have 2 of the opposite charge, 1 positive, 1 negative, they'll pull each other together through their fields, the electric fields that they generate. So I once heard one of these channel teachers say the law of attraction, well, it's just like magnets, like attracts like. And it's like, no, we all learned with magnets, like doesn't attract like. Two north poles repel, two positive charges repel. It's just a different kind of law for electricity and magnetism. And we were learned to picture these electrical fields as a field, as something that goes out from a charged particle or from a magnet forever and ever and ever, these lines of force that you might remember. So I've said that the nucleus of an atom is held together by the strong force. And the Earth, the Moon, the Sun, stars, the galaxies are held together by gravity. But everything in between, from atoms to asteroids, is held together by the electrical attraction. That's what keeps the mountains together. That's what keeps a cup together. That's what keeps our bodies together, is this electrical interaction. Because there's only four. It's not gravity. It's not the strong force. It's not the only one that's left. Is this electromagnetic interaction. That's what holds all the objects you see now, unless you're looking at the sun or the moon, together. But it also does more than that. I've said that gravity is what keeps the cup from flying off into the air, what keeps it from sinking down into the ground. Well, it's on the table, but what does that mean? It's the electrical repulsion now that between the table and the cup that keeps the cup from just going on down. It's what makes things bump into each other. That's also the electromagnetic force of what keeps solid objects solid. The electrical force, the electromagnetic force, is also responsible for all chemical interactions. Every time two hydrogen atoms combine with an oxygen one, that's the electrical force that's doing that. All the complicated chemical reactions that are going on when you digest something or in your brain, those are all the electrical interactions. So really, it's the most, what's the word I want? The most pervasive, I'll settle for that, the most pervasive force that we encounter in our daily lives. In fact, it's responsible for all five of our senses. That's something that I would have thought someone would have pointed out before, but I've never heard it pointed out before. Certainly, obviously, sight, because light is, as we all learned again, an electromagnetic wave, an electromagnetic radiation, and so we see by light. But sound, well, sound is the molecules bumping against each other. That's the electrical repulsion that's going on. Bumping against your eardrum, that's the electrical repulsion that's going on. What about touch? Well, touch again. How come my hand doesn't go through the podium? It's the electrical interaction between my hand and the podium. Taste and smell. Taste and smell are chemical analysis that's going on by your taste buds and by the sensors in your nose. Well, chemical analysis, that's chemical reactions that are going on. Again, all through that electrical interaction. So all five senses are there because of that one force, the electrical magnetic force. And that's just how it gets to our sense organs. How does it go from our sense organs to our brain? What kind of a signal goes up our nerves? An electrical signal. And in our brains, how do we then process it? All through this electrical chemical thing. So it's a pretty cool thing to think about how all that we really encounter, all our actions in the world, all our senses in the world are due to this one thing, the electromagnetic force or interaction. But that's not the coolest part. Here's the coolest part. We're going to get back to light and the light of the world. Remember, what is light? Light is electromagnetic waves. And as Einstein told us, it's not just waves. You can also encounter it as particles of light. Photons is what Einstein named it. And that's what we've called them ever since. So let's get back to this electric field. The electric field, as you say, an electric charge, sends out a field throughout all of space and time. But what is this field? What does it mean? Well, now we're going to get into some heavy stuff. Now we're getting into quantum field theory. But you all know quantum field theory because, of all those New Age writers who pretend to write about it. But, sorry, I just have to, never mind. What essentially we get from this notion of quantum field theory is what are these fields? What are these fields? What are they sort of made of? Well, they are quantized fields. That is, they're made of bits of some sort of particle. And for the electromagnetic interaction, those particles are, again, those photons. They're particles of light. So the electric field is made of particles of light. And we were all taught somewhere around 7th grade or before that atoms are mostly empty space. Remember that? Mostly empty space. There's just these outer electrons and this tiny little nucleus, and in between there's nothing going on. Well, it's kind of true. It's kind of true in the sense that if I were to drink all the water in this cup, we'd say the cup is empty. But of course it wouldn't be empty, it'd be full of air. So it is with atoms. You may well drink. So it is with atoms. What holds an atom together again? The electrical attraction between the outer electrons and the nucleus, that electric field. What is that electric field? It is the nucleus and the electrons constantly and continually exchanging photons, exchanging particles of light. Every atom in the universe is filled with light, is held together by light. When you think of, again, that water molecule, those two hydrogen atoms that are held to the oxygen atom, how do those two H's connect to the O? Well, we said through good times. We said through this electrical connection. That is, they are sending out messages of light to each other, back and forth, saying, hold on here. So every water molecule in our bodies, and we're 70% water, is held together by light. Our bodies are filled with light. The cells in our bodies, when they do their things, when all these different structures, they're doing all these complicated chemical things, all these complicated chemical things are mediated by the electromagnetic interaction. They're all constantly sending out particles of light. That's how our cells work. I truly think sometimes that when the mystics say that everything is light, that they intuited this. They didn't actually physically see these photons because they're not getting to their eyes. But I think that they may have intuited all this light that's going on every nanosecond in every atom in the universe. I remember Yoda said to Luke Skywalker, luminous beings are we, not this crude matter. And he almost had it right. Luminous beings are we, yes. This apparently, but not actually crude, matter. When the mystics talk about our body of light, not the people who learn from the people who learn from the people who learned from the mystics and just got the words, but the mystics themselves, when they talk about our body of light, this is it. Not metaphorical, not some other kind of thing. This is our body of light. The physical is the spiritual is the physical. This is indeed a world of light. And so it is.